Could we all turn and talk to the people at our tables to try and label this generic graph of the photoelectric effect? Okay, so thank you for talking. That's awesome. Can I hear what this orange arrow is, please? Yeah, so this is the light we're talking about in the problem. The light that has a frequency, okay? And another word for this light is photon. So you may see it as photon. And what is this light striking? Good. So the zinc metal for the binding energy. Okay. So if you don't already have it in your picture, it could be good to add some electrons. And this is because what is this green arrow representing? The path of the electron. So this electron is being ejected. What do we know about the photoelectric effect? What are some equations? It's good to start getting to know some trends, like what things can be mentioned in the question that'll lead you to certain equations, because the equations we have in this class, they're adding up, and it's good to recognize where we can use them. Does anybody have an equation for the photoelectric effect? Yeah. Okay. So I believe I heard in the back, E photon equals E binding plus kinetic energy. So E photon would be the energy, photon of light. E binding would be the amount of energy that the metal is holding onto the electron with, which is why I underlined it in gray. And then what does this green arrow represent? Kinetic energy. So I'm going to add that. This is the kinetic energy of the electron. So whatever energy from the photon of light that isn't used to overcome the binding energy, so the excess amount of energy is going towards the kinetic energy of the electron. So as far as what we know in the question, what do we know about E-binding? Yeah, so we're given E-binding. Right here, it's 417.8 kilojoules per mole. And then what do we know about E photon? We're not given as pretty of a number right in front of us, so we're gonna have to just work on E photon, and let's come up with an equation for that. So we'll turn and talk, maybe look through some lectures briefly, and then let's look into how we can solve for kinetic energy. So now that you've looked, we have a good group of equations. And thank you for everybody who shared the equation for the second part, the de Broglie's wavelength, but let's tackle that last. So for E photon, we have some constants. So let's get some constants up here. We have H, which is Planck's constant right here. And then we have nu. And this is the frequency of light, which we're given. So now we can try and solve this. We could all plug that in, see what we get if you have any questions. Got it, yeah. Thank you for the question about the evacuated glass. This is important because the evacuated glass has all the air removed. So it means when we're measuring something like the photoelectric effect, we're going to get a more accurate measure of the energy and the behavior of this electron because our electron won't collide with any air molecules. Yeah. Thank you for that question. So then kinetic energy is another constant. We're always going to have the same mass of an electron that we're given. And then U represents what? Can I have a reminder what U represents? Yes, the speed. Okay. So now we can find kinetic energy. And what I think is helpful is when we rearrange the equation.